International Space Station. The International Space Station ISS is a vast orbital laboratory constructed and maintained through the collaboration of 5 space agencies: NASA United States, Roscosmos Russia, JAXA Japan, ESA Europe, and CSA Canada. It is the largest space station ever built, primarily designed for conducting experiments in microgravity and studying the space environment. The station is divided into 2 main sections: the Russian orbital segment ROS, managed by Roscosmos, and the U.S. orbital segment, managed by NASA, JAXA, ESA, and CSA. A notable feature of the ISS is the integrated truss structure, which supports the large solar panels and radiators attached to the pressurized modules. These modules serve various purposes, including research, living quarters, storage, spacecraft control, and airlock operations. Visiting spacecraft can dock at the ISS using its 8 docking and berthing ports. The ISS orbits Earth at an average altitude of 400 kilometers (250 miles), completing one orbit approximately every 93 minutes, resulting in 15.5 orbits per day. The ISS program is a merger of 2 previous plans for crewed Earth orbiting stations: the United States Space Station Freedom and the Soviet Union's Mir 2 station. The first module of the ISS was launched in 1998, with major components transported via Proton and Soyuz rockets and the Space Shuttle. The first long-term crew, Expedition 1, arrived on November 2, 2000, marking the beginning of continuous human presence on the station, which has lasted for over 23 years. As of March 2024, 279 individuals from 22 countries have visited the ISS. Future plans include additional modules, such as the Axiom orbital segment, before its scheduled deorbiting by a dedicated NASA spacecraft in January 2031. The ISS provides an unparalleled platform for scientific research, offering power, data, cooling, and crew support for experiments. While small uncrewed spacecraft can conduct zero-gravity and space exposure experiments, the ISS allows long-term studies with human involvement. Researchers benefit from shared resources, timely data access, and the ability to adjust experiments in real time. Fields of study include astrobiology, astronomy, physical sciences, materials science, meteorology, space weather, and human health. One highlight is the alpha magnetic spectrometer AMS, crucial for dark matter research and comparable in significance to the Hubble Space Telescope. The AMS's power and bandwidth needs make the ISS an ideal host. The hostile space environment, with its intense radiation, high vacuum, extreme temperatures, and microgravity, challenges life forms. Yet some extremophiles and tardigrades can survive through desiccation. Medical research on the ISS assesses the effects of long-term space exposure, such as muscle atrophy, bone loss, and fluid shifts, critical for future interplanetary missions. The National Space Biomedical Research Institute (NSBRI) conducts medical studies on the ISS, including the Advanced Diagnostic Ultrasound and Microgravity Study, where astronauts perform ultrasound scans under remote guidance, relevant for emergency and rural care on Earth. In 2020, scientists reported that Deinococcus radiodurans bacteria survived 3 years in space, supporting panspermia theories. Remote sensing and astronomy research on the ISS has increased, studying Earth's atmosphere, cosmic phenomena, and space environments, significantly advancing our understanding of the universe. The International Space Station ISS is a multinational project with components manufactured around the world. U.S. modules like Destiny, Unity, the integrated truss structure, and solar arrays were built at NASA facilities in Alabama and Louisiana, then assembled at the Kennedy Space Center. Russian modules, including Zarya and Zvezda, came from Moscow's Khrunichev Space Center, with Zvezda originally intended for the Mir 2 space station. The European Space Agency's Columbus module was produced in Germany, while other ESA modules like Harmony and Tranquility were built in Italy and transported to the U.S. for final launch preparations. Japan's Kibo module was assembled at various high-tech facilities in Japan before being shipped to the Kennedy Space Center. Canada contributed the mobile servicing system, which includes the Canadarm2 and Dexter Grapple, built in Canada and the U.S., under the Canadian Space Agency's direction. The mobile base system for Canadarm2 was constructed by Northrop Grumman. Under the Outer Space Treaty, the U.S. and Russia are legally responsible for all modules they launch into space. To safely decommission the ISS, several options were considered, including natural orbital decay, boosting the station to a higher altitude, or a controlled deorbit into a remote ocean area. By late 2023, NASA decided on a specially designed spacecraft to deorbit the ISS, with proposals for such a vehicle still being solicited. Initially, Russia planned to reuse modules from the ISS for the OPSIC station. Modules like the NAUKA, launched in 2021, were to be repurposed due to their remaining operational life. The U.S. had similar ideas for using ISS hardware for other missions, but most modules were not designed for disassembly and would be discarded. In July 2018, the Space Frontier Act sought to extend IS operations to 2030 but failed in the House. However, the leading Human Spaceflight Act, passed in 2018, and provisions in the CHIPS and Science Act, signed by President Joe Biden in 2022, supported extending IS operations to 2030. NASA plans to deorbit the ISS in January 2031 using a dedicated deorbit module, directing remnants into the South Pacific Ocean. This spacecraft, docking with the ISS a year before re-entry, will execute burns to lower the station's orbit before a final deorbit burn. As of 2024, the deorbit vehicle is still in the funding stage. Thanks for exploring the incredible International Space Station with us. If you enjoyed this journey, please like, share, and subscribe for more exciting space content. Have any questions or thoughts? Drop them in the comments below. Until next time, keep reaching for the stars.